Hello everybody. In this video, we are going to start to look at ways to represent data. Because just looking at a long list of numbers or looking at just things in a chart aren't always as helpful in interpreting the data and being able to make conclusions based off the data. So we're going to introduce how to represent it. In this video, we're going to look at dot plots, bar graphs, and histograms. So the frequency is a vocab word that means the number of times a value in a data set occurs or appears. And in our first representation, we're going to be looking at a dot plot, which is also known as a line plot, and it is a representation of a frequency table. It shows the frequency of each data point. So we're looking at individual data points here. So in this example, the graph to the right, this dot plot here, represents how many minutes students take eating breakfast in the morning. So, question 1, we can now make conclusions by interpreting this graph. We're not looking at a list of data points. We have taken that, we have organized it into a dot plot. Question 1 says, how many people spent 4 minutes eating breakfast? So I look at 4. Each dot represents a data point or a person. So 2 people, because there are 2 data points. How many people spend at least 9 minutes eating breakfast? So this is going to be anything that is bigger than or equal to 9, at least 9 minutes. So they can spend 9 minutes or they can spend more than 9. So if I look at starting at 9, there's 1, 2, 3, then I go to 10, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15. So there are 15 people, or students, who spend at least 9 minutes eating breakfast. The next question says, what was the most time? What was the most time spent eating breakfast? Well, that would be the highest amount of time, which was 12 minutes. Number 4, what is the frequency of students, or how many students ate breakfast in 10 minutes? So we just count at 10. 1, 2, 3, 4, 5, 6, 7. That would be 7 students. How many students took part in this scenario? That's where we have to count all the dots. So that would be 40 people. You just want to be careful how you're counting. Just make sure you're counting every dot because every dot represents a person. So that's how you interpret a dot plot. The you try now, try it real quick. Look at it, pause the video, try it out because I've already got my work down there. And then I'll scroll up so you can check it out. So here is my work for this you try now. A couple other questions that you may see for dot plots. Let's go to the next question. Next question is a bar graph. Bar graph is used for qualitative data. So we're looking at qualities here, not something that can be counted or measured. We're saying, okay, birthday by students by month, that's a quality. Your birthday's in January or August or something like that. So how many students were surveyed? So we are going to look to see how many people are in each bar. So in January, it's in between 2 and 4, so that's going to be 3. February is 4, so on and so forth. So we figure out how much is in each bar, and then we add all those numbers together. So there's 60, wrong number. There are 63 students in the survey. Which month had the most birthdays? So there we're going to look for the highest bar. That looks like June. How many more birthdays does October have than August? Well, October had 8. August only had 1. So 8 minus 1, that's going to be 7 more birthdays. What months have the same number of birthdays? So now we're looking for bars that have the same height. So you'll notice January and not February, sorry. January and April. Those both had 3. February and November. Those both had 4. May and October. Those both had 8. And then September and December. Those both had 7. So those months have the same, those month pairings have the same number of birthdays. Last question is, what is the frequency of April? That's going to be 3. 3 students had birthdays in April. So you try now again with another bar graph. This one's a little bit more complicated because you'll see that each person has 2 bars to represent them. One for Walmart and one for Target. So pause the video and try that out, and then I will scroll up so you can check it out. Here's the work for that one, 1 through 6. Okay, so moving on to our histogram. A histogram is used for quantity. Here we're looking at numbers and things we can count or measure. So this uses bins. Each kind of bar here is called a bin. And you may ask yourself, how is this different than a bar graph? Well, you notice in a histogram how these bins all touch each other. And up here in the histograms, up here in the bar graphs, those are all separated. Okay, in between each thing that you're measuring. So like John, Mike, Sarah, Alice, and Sue, those aren't all connected. They're separate. So in a bar graph, things are separate. In a histogram, things are connected by bins. So you'll notice each green bin represents 0.5 here, 6 to 6.5, 6.5 to 7. And it's going to, in this one, this graph shows how much sleep a student got after 50 days. So there are 50 data points in here. And we can't tell the individual data points, but that's why we have these bins. Because we know looking at 6 to 6.5, that frequency is 2. So that's telling me there were 2 days where this student got in between 6 and 6.5. I don't know how much sleep he got, but I know it was in between 6 and 6.5. So this question is saying, how many days did he sleep 6.5 hours? Well, again, we can't tell individual data points. So we don't know specifically when he slept exactly 6.5 hours. Okay? But for the next question where it says, how many days did he sleep between 6 and 8 hours? Well, that we can look at. We're looking at in between 6 and 8. So 2 days for 6 to 6.5, 9 days here, 12 days there, and 12 days there. So if we just add those all together, 35 days he slept in between 6 and 8 hours. Okay. How many days did he sleep more than 8.5 hours? So more than 8.5 hours. we're looking at these two bins, and that would be 4 days. Okay, so histogram, we cannot determine individual data points. Instead, we put these data points in intervals of equal width. So maybe that might be important to note. So can't determine individual data points. Instead, it uses bins to sort the data, which that means it puts data into intervals of equal width. And that equal width is called the bin width. So this bin width is 0.5 because each bin is 6 to 6.5, 6.5 to 7, that's 0.5. Okay, so that's why for this first one, how many days did you sleep? 6.5. We can't determine that because that's looking for an individual data point, and we can't do that with a histogram. Okay, so you try now is below. Try it out. Pause the video for a quick second, and then let me know. No, don't let me know. I'll scroll down in a quick second for you to see it. So there's the work for that. You try now on the histogram. There is one more representation of data, and that's going to be in the next video. It's a box and whisker plot, or a box plot, but you've make sure you practice dot plots, bar graphs, and histograms on your homework so that you're ready for this quiz. Email me if you have any questions. Hope you're all doing well.